Welcome to our channel. In this session, we are going to discuss about some mathematics of cryptography, algebraic structures. Those are group, ring, and then field. First, we will move to group. A group is denoted by using G comma some dot. Now group is simply some set of elements over the binary operator dot. Some set of elements over the binary operator dot for addition and multiplication. Now a group follows some axioms. A group follow some axioms. Now we will discuss what are the axioms that are followed by group. The first one, closure property. The first one, closure. Closure means if A and B, assume A and B are the two elements that belongs to G. A and B are the two elements that belongs to G. A dot B is also belongs to G. That means my operation, if I performing this particular operation between A and B, A dot B also belongs to G. This is called closure property. This is called closure property. Okay. Second one, associativity. Associativity. Consider any three elements A, B, C. A dot B dot C is equal to A dot B dot C. For all A comma B comma C belongs to G. Consider any elements, for example, three elements A comma B comma C. It satisfies the associativity property. Next one, A3, identity element. Identity element. Identity element in the sense, consider an element E. Consider an element E such that A dot E is equal to E dot A is equal to A. That means we have some identity element in the group. With A dot E dot A, it produces same value. This is the property of identity element. And the next one, A4. Simply this is called inverse element. Inverse element. Inverse element means for an element A in the group. Consider an element A in the group. There exists an inverse element A dash. The element A in the group. If there exists an element A dash, inverse element A dash is also existed such that A into A dash or A dash into A is equal to the corresponding element belongs to G. Clear? So these are the four properties that are supported by group. And one more group is there, abelian group. The name of the group is abelian group, means along with the four properties, if it satisfies additional property A5, that is commutative. If a set of elements that satisfies commutative property also, that is called abelian group. Commutative property also, that is called abelian group. Okay, commutative property in the sense A dot B is equal to B dot A. This is called abelian group. Okay, now I will explain all this with one example. With one example, along with some basic definitions are there. What are those? Finite group, infinite group. Finite group means a group that consists of finite number of elements. Infinite means it consists of infinite number of elements. Order means the number of elements present in the group is called order of the element. Anyway, I will explain the group with one example. Assume my example is Zn comma plus. My example is Zn. What is Zn? Zn is set of residue integers. You already know the concept of Zn. Zn is residue integers, means all possible integers. Assume my dot is plus. Here dot is any binary operator, either addition, multiplication, subtraction, etc. Assume my dot is plus. Now check. Consider any element, for example 2 comma 3 are the two elements. 2 comma 3 are the two elements that are belongs to Zn. Now 2 plus 3, my operation is plus. Observe, a comma b belongs to the group a plus b, a dot b. Here dot is replaced with plus. The addition 5, it is also belongs to Zn. Zn consists of all possible integers. Zn means all the possible integers. Take any two elements. The addition also consists of some element that is also present in Zn, that is closure property. 2 plus 3 plus 4 is equal to 2 plus 3 plus 4. Both are same or not? So 2 plus 7 plus 2 9, 5 plus 4 9. That element belongs to Z. That means plus satisfies this associativity property. Identity element. What is the identity element for addition? 1. So identity element for addition? 0. For example, 2 plus 0 is equal to 0 plus 2 is equal to 2. Go to the previous definition. A dot E is equal to E dot A is equal to A. My dot is replaced with addition. Inverse element. For example, 3 is my element. What is the inverse of 3? Inverse of 3 is equal to 7. So, inverse of 3 7. 7 is also present in Zn. For example, if you are taking 7, inverse of 7 is 3. 3 also present in Z1. So, for any element, that inverse is also available. That inverse is also available. Now, abelian group, commutative. So, commutative means 2 plus 3 is equal to 3 plus 2. So, I think Z plus Zn plus 1, it is a group, and also it is an abelian group. But all not the operations are abelian. For example, matrix multiplication. Matrix multiplication is not commutative. Why? Because A into B matrix is not equal to B into A. So matrix multiplication is only closure, associativity, identity, inverse, not commutative. This is both abelian also. This is the group. Next I will move to ring. Coming to the ring. A ring R is denoted by R comma plus comma star. So a ring R is simply a set of elements over two binary operations, addition and multiplication. Two binary operations, addition and multiplication. Okay. Now coming to addition, simply ring is an abelian group. Ring is an abelian group over addition. Ring is an abelian group over addition, meaning is with respect to addition operation, ring satisfies all the axioms A1 to A5. Ring is an abelian group means if you are using addition operation, the ring satisfies the closure property, associative property, identity, inverse and commutative with respect to addition. Here my meaning is with respect to addition. A1 to A5 are satisfied. Clear? Now coming to multiplication. So M1 specifies closure. M1 is closure under multiplication. So for addition it is clear. For addition all the 5 properties are satisfied. That means ring is an abelian group also over addition. Coming to multiplication. Multiplication satisfies the closure property like addition. Multiplication satisfies the closure property like addition. What is mean by closure property? A comma B are the two elements that belongs to ring, and A into B is also belongs to ring. Yes or no? A comma B two elements belongs to ring, and the multiplication between the two elements also belongs to the ring. That is called closure. Now clear? I will erase this one. Now second one, multiplication of associativity. So now the multiplication also satisfies associativity property. So we know what the associative. A into B into C is equal to A into B into C. Now multiplication satisfies associativity property. Now coming to M3, the third axiom. This is the axiom numbers. The third axiom is distributive. Distributive means simply the multiplication is distributive over addition. Suppose A into B plus C. If this is existed in the ring, then AB plus AC is also belongs to the ring, or A plus B into C is equal to AC plus BC. Generally these are called distributive laws. So multiplication under distributive. These three properties are satisfied over multiplication. Again, the next one is if the ring is a commutative ring, like if a group is an abelian group, in the similar sense, suppose if a ring is a commutative ring, then only it satisfies the medicinal property. If the ring is a commutative ring, that satisfies that additional property, commutative. So commutative means you know the meaning. A into B is equal to B into A. If it satisfies this property, then it is called commutative ring. If it does not, means this is a normal ring. If it satisfies M1, M2, M3 only sufficient, that is called a ring. If it satisfies M4 also, that is called a commutative ring. And one more point is there, integral domain. Integral domain in the sense, along with all the properties, if it satisfies two more additional properties, M5 and M6. M5 in the sense multiplicative identity. M5 in the sense multiplicative identity. So for every multiplication we have identity element. What is that one? Simply A into 1 is equal to 1 into A is equal to A. So here 1 is the multiplicative identity. Okay. So along with this property, the ring is called integral domain when if it satisfies two more additional property. The first one is if in every element we have some multiplicative identity is there, and M6 in the sense no zero divisors. No zero divisors. No zero divisors in the sense, the meaning is if A and B are the two elements, A and B are the two elements, and AB is equal to 0, AB is equal to 0, then either A is equal to 0 or B is equal to 0. Either A is equal to 0 or B is equal to 0. No zero divisors. If it satisfies, this is integral domain. Now observe, almost all the properties are satisfied except this one. Remember, ring. Ring no need have multiplicative inverse. The inverse is only for addition. Ring doesn't need any multiplicative inverse. Clear? These are the properties of ring. Now I will erase. I explain this one with one example. For example, we have Z. We have a residual modulo Zn is set of integers. Same thing, we already know the closure property 2, 3. Assume 2, 3, 4 are some elements. 2, 3, 4 are some elements that belongs to Z. 2 plus 3. The addition of any two numbers also belongs. So, closure for addition. 2 into 3. Multiplication. Closure for example, A1, M1. Closure for addition belongs to Z. The multiplication is also belongs to Z. 2 plus 3 plus 2 is equal to 2 plus 3 plus 2. The associativity for addition 2 into 3 into 2 is equal to 2 into 3 into 2. The second property, the associativity for multiplication. This is also satisfied. Now, according to that one, inverse element, third one, identity element, 2 plus 0 is equal to 0 plus 2. This also belongs to ring. 2 into 1 is equal to 1 into 2 is equal to 2. 1 is the identity element for multiplication. Multiplication identity is also existed. Next property, inverse. So, for example, 2 plus minus 2 is equal to 0. So, minus 2 is the inverse for addition. Remember, for the ring, multiplicative inverse is not required. Only addition is required. Now, distributive. 2 into 3 plus 4 is equal to 2 into 3 plus 2 into 4. Distributive is also satisfied. Commutative. 2 plus 3 is equal to 3 plus 2. 2 into 3 is equal to 3 into 2. Observe, even though perform all the operations, every element belongs to Z. Then we obviously call Z is a ring. The only thing you need to remember is ring over multiplication inverse is not required. Next, I am moving into the third one, field. Now coming to field. Field is denoted by F plus star, like ring. Field F is simply a set of elements over two binary operations, addition and multiplication. Simply, F is an integral domain. What is the meaning of this one? F is integral domain in the sense F satisfies all the properties from A1 to A5 along with M1 to M6. Clear the point? A1 to A5 means closure over addition. What are the properties? Addition, closure, associativity, identity, inverse and commutative. M1 to M6 means over multiplication, closure, associativity, distributive, commutative, multiplicative identity, no zero divisors. If all the properties are satisfied, that is called a field. So F is simply an integral domain. Integral domain in the sense It satisfies A1 to A5, M1 to M6. In the ring, I used one word. Ring no need have any multiplicative inverse. But coming to field, field have to satisfies one more additional property, that is called multiplicative inverse. So ring does not have, field consists of multiplicative inverse. We know that one. What is multiplicative inverse? If A is an element that belongs to F, A is an element that belongs to F except 0. Remember, A is an element that belongs to F if there exists an element A inverse. If there exists an element A inverse, now A into A inverse is equal to 1. Consider an element A from the F. If there exists an element A inverse in the F such that A into A inverse is equal to 1, this A inverse is called multiplicative inverse for A. If this property is also satisfied, that is called field. That is called field. Now, for example, R is set of real numbers. R is set of real numbers. Now, R is a field. Real numbers. R is a field. So, A1 to A5, M1 to M6 already explained. All the properties are satisfied. Now, if X is a number belongs to R, automatically we have a number. Real number means fractions also available. We have a number 1 by X is also available. So, what is X into 1 by X? The answer is 1. So, R is set of real numbers. If any set of real numbers is called a field. These are group, ring, field. Step by step we are adding some properties. Okay. Thank you.